For this first flat ground projectile motion problem, I am given a velocity of 25 meters per second at a 30-degree angle above the positive x-axis. I need to find the distance, the final velocity, and the maximum height. So I'm going to start off by saying this one here, the distance, the maximum height, is going to be its own unique problem by itself. Now, what we're going to need to do for the other two problems is split our information up into x and y. I want to talk about really quickly how these equations are going to come into play. There is no acceleration for the x direction, and because there's no acceleration for the x direction, as far as the x is concerned, the first equation is now useless. V final equals V initial. The third equation is also useless because this would cancel out. V squared equals V initial squared. The second equation simplifies to just this, which we'll be using as delta x equals V naught t. That's the only information that ever works for the x direction in these projectile problems. Now, the next thing I want to talk about is how we have this football being punted at a 30-degree angle. So we can't actually use the 25 meters per second in any of our calculations. We have to use SOHCAHTOA to split it up. So I built a right triangle in which I will have Vx and I will have Vy. For this one example, and this one example only, I will show you the details of SOHCAHTOA. So 25 is the hypotenuse and Vx is the adjacent side. So you're using CAH. Cosine of theta is adjacent over hypotenuse. So that's cosine of 30 degrees equals Vx over 25. Or in general, what I'll be saying in the future would just be 25 cosine 30. For the y direction, 25 is the hypotenuse and Vy is the opposite of the angle. So we're using the SO and SOHCAHTOA. So the sine of 30 degrees is the opposite, which is Vy, over the hypotenuse, which is 25. So Vy is 25 sine of 30. Using a calculator is going to reveal to me that the V initial for the y direction is going to be 15 meters per second. I'm sorry, not 15 meters per second, 12.5 meters per second. And then 25 times the cosine of 30 degrees is going to be 21.7 meters per second. So we'll go V initial for the x is 21.7 meters per second. Other things that I know, by default, the delta y is 0. It started at the ground and went up into the air and it landed on the ground. It doesn't matter that it traveled this distance d. The point is that its elevation at the beginning was ground level and its elevation at the end was at the ground, so delta y is 0. Acceleration is caused by gravity, so that's a default negative 9.81 meters per second squared. We talked about the x direction for velocity. I can conclude for sure that the v final in the x direction will also be 21.7 meters per second. Due to the symmetry of this problem, I can conclude that the v final will be negative 12.5 meters per second. So it's 12.5 up. When it took off, it landed at 12.5 down. That is only because this was a flat ground problem. The x direction, as shown right here, v final equals v initial. All right, so I have quite a bit of information. I'm going to go ahead and start doing some solving. To take the equations, there are three equations right here. Copy these and bring them with me as I work on this. The x direction, as I said before, there's only one thing that's going to work for the x direction, and that is delta x equals v initial t. I don't know delta x and I don't know t, so that's not going to help me right now. The y direction, I get a lot of help. I can use the first equation to find time. I can use the second equation to find time. And the third equation already confirms something that I know. So since the only piece of information that I can still solve for the y direction is time, I may as well go do that. So I'm going to go v equals v initial plus at. This will be negative 12.5 equals 12.5 plus negative 9.81 t. So that will give me a negative 25 divided by a negative 9.81 is 2.55 seconds. To prove to you that it works, if I had used the other one, delta y equals v naught t plus 1/2 at squared, this would be 0, and I would have 12.5 t plus 1/2 negative 9.81 t squared. Factor out a t, it would be t 12.5 minus 4.905 t. So one of the t's would be 0, and the other one will be 12 divided by 4.905, negative 12 divided by negative 4.905. And once again, negative 12.5 divided by negative 4.905. 2.55 will come out as my time. Apologize about those verbal errors. As I said before in the first video, time can translate right on over to the x, so sure enough, I will bring time over here. Delta x is 21.7 times 2.55. So 21.7 times 2.55 is 55.3. So I've solved d, the distance 55.3 meters. Next thing is let's focus on the final velocity. For the x direction is 21.7. For the y direction, it's negative 12.5. So that's a downwards arrow. Normally, I would have to use Pythagorean's theorem, 21.7 squared plus 12.5 squared, all under square root, and I would get 25. I would use SOHCAHTOA as well to do the tangent of theta is 12.5 over 21.7. Now we get 30 degrees. Now I do know, due to the symmetry of a flat ground problem, that the final velocity and initial velocity would be the same, just that the angle, instead of being 30 degrees above the positive x-axis, would be 30 degrees below the positive x-axis. I'm going to go ahead and take this stuff away. I still do want to know about those initial velocities though. I really only need the initial velocity for the y direction. I promised you that the particular question referring to the height was a y direction only problem, and it was a special type of problem. So the v initial for the y direction is still going to be the 12.5 that I solved earlier. But v final for the y direction is 0. And delta y is not 0. I don't know what it is. That's actually what I'm solving. The acceleration, even though we're only going to the peak, it's still negative 9.81 meters per second due to gravity. To reiterate, the reason why the velocity for the y direction is 0 is because you're at a peak. At the peak, vy is 0, vx is constant. So vx never changed from the 21.7. At the peak, your velocity is perfectly horizontal. Alright, so this is the information I have for the y direction. I don't have time. That's fine. I don't need time. The third equation is going to work perfectly for me. All I need to do is figure out what is delta y. So the v final is 0. That cancels out. 12.5 squared plus 2 by negative 9.81 times delta y. I'll square the 12.5. Doing so gives me 156.25. I move it to the left, it's now negative. Divided by 2, divided by negative 9.81. And I'm left with 7.96 meters. So the maximum height achieved is 7.96 meters. Moving on to this second problem. This time I'm given the distance and I'm given the height. So here's what we'll do for the second problem to solve this. I'm going to rush through this fairly quickly. The video is going to speed up, but I'm going to follow the same format that I did before. My only goal is to determine the initial and final velocities. So I'm going to stop talking and the camera's going to speed up as I solve through this. So to conclude, I can say that the initial velocity was 19.2 meters per second and an angle of 63.6 degrees above the positive x-axis. And the final velocity was 19.2 meters per second at a 63.6 degree angle below the positive x-axis.